counter. You should have this idea. Now this will be represented by clockwise, this will be counterclockwise, and this will be clockwise. Just have small idea about this. Now please look here. I have shown the arrow mark. It is rotating in the there A is rotating in the clockwise direction. And one of you please tell me the gear A is meshing with which gear? There. The gear which is meshing with the gear A. Gear B is meshing with the gear B. And gear C is meshing with the gear A. Gear C is meshing with the gear A. And how to find out the velocity ratio? Just I'll be giving you a small example. Here. Now let me look into the velocity ratio of the gears A and B. They are engaging each other. Now NB by NA is equal to the output velocity to the input velocity will be equal to TA by TB. That is equal to dA by dB. Anyone can able to understand? These are the two gears I have taken. Gear A is meshing with the gear B. So output gain is B here. So definitely NB by NA is equal to TA by TB. That is equal to TA by dB. You say it is equation 1. Now the gear C is engaging with the gear D. Please look into the figure. The gear D is engaging with the gear C. Why I am showing you many times? Because they will be giving us the problem. We should have to slightly analyze it and try to do the problem. The gear C is engaging with the gear D. Then output gear is D and input gear is C. Then ND by ND by NC is equal to. Now here you need not worry. In the reverse direction, it is TC by TD, that is equal to TC by TD. This is the second equation. Now another one. Okay, now let me find out what is the velocity ratio of this compound gear train system. Multiplying this NB by NA into ND by NC, that is equal to TA by TB into TC by TD, and that is equal to TA by TB into TC by TD. This is the velocity of this system. Now here one can see this. The gear D, B and gear C are on the same shaft. Even though these gears are having the different diameters, what happens? The speed of these gears should be same because they have been mounted on the same shaft. So that means the speed of the gear B and speed of the gear C will be equal. That means from the figure, the speed of the gear C is equal to speed of the gear B. The speed of the gear B and speed of the gear C will be equal. So that ND by NA is equal to this. ND is what? Output gear, and NA is the input gear. This is how we can able to calculate the velocity ratio of a particular gear system. Now here, instead of giving you TC, TD, TA and all this, they will be giving us the numerical values. We can able to do the problem. You understand? Very simple way you can able to remember this. Okay. Now, this is I had given an example of the rack and pinion, how it will be useful. Okay. I don't want to show that once again. Here the simple gear train, the velocity ratio of the simple gear train, how to find out. Already I told these two are the two gears. Output gear to the input gear. N2 by N1 is equal to T1 by T2, that's equal to T1 by T2. Between these two gears, this is the output gear and this is the input gear. Then N3 by N2 is equal to T2 by T3, that is equal to D2 by T3. And finally, the velocity ratio of the whole system will be calculated by multiplying these. Then finally, what we will get? N3 by N1 is equal to T1 by T2 into T2 by T3. That means T1 by T3 is the velocity ratio of the system. How I have shown here. Okay. Now, the same thing I have shown. Okay. Here, directly you cannot do like mathematics. If you do like this, if it is carrying 5 marks, it will be given only 2 marks. You have to write, consider the three gears are matched as shown in figure. Let the driver gear is one is the driver gear, and 2 is the intermediate gear, and 3 is the follower gear or driven gear. The velocity ratio of the machine gear 1 and 2 is first one. The velocity ratio for the machine gears 2 and 3 is this. Then finally, the velocity ratio is given by this one. This. And in a comfort gear, you write like this. Finally, from the figure, we find the gear C and gear B are mounted on the same shaft, so that the velocity of the two gears, that is NC and ND, will be equal. But the teeth will not be equal and the diameter may not be equal, but the speed will be equal. So that this speed will get cancelled. Finally, we will get ND by NA is equal to this value. Okay, only in the simple gear train and compound gear train will get the problems. Okay, in the other gears will not get the numerical problems and all this. Now, to make practice ourselves, I'm going to show you other one that I'm giving it to do yourself. Now, let me find out the velocity ratio of this gear train. It looks complicated. See, I have taken other one also. Slowly it is rotating. How it is engaging, I'm showing. Now, if I have taken gear 1, 2, 3, 4, 5, and 6 are the gear train, it forms the compound gear train. Because in this, the gears 2 and 3 are one shaft, and gears 4 and 5 are mounted on the other shaft. So definitely there are more than one gear mounted on two gears or two shafts. Definitely it will be a compound gear train system. Right. Next, let the gear 1 is a driver gear. I cannot throw it. If you want, you can take the 6th gear as a driver gear. Okay. And let the 6th gear, gear 6 is the driven gear. It is a follower gear. And gears 2, 3, 4, and 5 are the intermediate gears. From the figure, consider the machine gears 1 and 2. Consider the machine gears 1 and 2. Slowly we'll try to do machine gears 1 and 2. That is, the 2 is the output gear and 1 is the input gear. That is, N2 by N1 is equal to T1 by T2. That is equal to T1 by T2. Okay. Okay. Now next, consider the next in gear 2 and 3. If I took it will be wrong. 2 and 3 are mounted on the same shaft, but the gear 3 and gear 4 are meshing each other. One can see that the gear 3 and 4 are meshing. Gear 3 and 4 are meshing. Definitely 4 and 3. That is N4 by N3. N4 by N3 is equal to P3 by T4. That is equal to P3 by P4. Second equation. Okay. Now consider the other gears. There are 5 and 6. The gears 5 and 6 are meshing. So 6 is the output and 5 is the input. 6 is the output. N6 by N5 is equal to 5. T5 by T6. That is equal to T5 by T6. Equation 3. Finally, the velocity ratio of the gear train is can be obtained by multiplying the equations 1, 2, and 3. That is N2 by N1 into N4 by N3. Be careful when the problems are very simple. Our ignorance will be more. Definitely, our 90% of it will be committing the mistake. Correct? No? Because we will be doing it. So we are not going to think more about this. A small mistake you do, everything will be waste. So N2 by N1, N4 by N3, and N6 by N5. N5 is equal to anyone you take. The T you can take and V or you can take or everything you can take. But here I am going to take only the T to show that is T1 by T2 into T3 by T4 into T5 by T6. This is no problem. Now here what I have to do, this is the velocity ratio of a particular gear system. But here what happens, the gear 3 and 2 are mounted on the same shaft. That means the speed of the gears 2 and 3 are equal. N3 will be equal to N2 because the two gears are mounted on the same shaft and gears are 4 and 5 are mounted on this 4 shaft. N4 is equal to N5 and N4 is equal to N5. N4 and N5 will be same. You can see that N4 and N5 this will get cancelled and 2 and 3 will get cancelled. So definitely N6 by N1 is equal to T1 into T3 into T5 divided by T2 into T4 into T6 is the velocity ratio of this particular gear train system. You can able to understand. Very simple pattern. Very simple to understand and very simple to do the problems. Okay, you can do this. How many of you are not able to understand? Please raise your hand. I can able to once again explain because there will be one problem on this. Okay, in the final examination also there will be one definite problem should be there on this. The same thing I have written. You can see that. Okay, 1, 3, 5 and this one 1, 3, 5 and 2, 4, 6 output. Okay. Now let me look into the reverted gear train system. Reverted gear train system is one. This mechanism is called by this reverted gear train system because the input shaft and the output shaft are on the same line. They are coaxial. That kind of arrangement is called as the reverted gear train system. That system is called as reverted gear train system. You understood my point? Okay. And here, to make you to understand, I wrote one 3D model of it. You can see that the first gear, this is the driver gear, and this is the other intermediate gears, and this is the last and the driven gears. You can see these two gears are on the same line, on the same axis. This is how this featured outlook of the gear is called as the reverted gear set systems. Okay, just try to remember. And another one, epicyclic gear train system. Epicyclic gear train system. To make you to understand, I have taken a 3D model of it. A simulated model to show that epicyclic, there will be one arm will be there. You can see that arm, and this will be a sun gear. And these are called planetary gears. Just like it is a sun and planets around which it will be rotating. In the similar way, this gear 1, 2, and 3 are the planetary gears, and in between this will be called as the sun gear, and this will be called as arm. This is called as arm. Okay, and this particular setup is called as called by epicyclic gear train systems. Called by epicyclic gear train systems. I don't want you to get into the depth of it. Okay, please try to remember this. Okay, and if it is possible to do the practice of this figure, you can see this. You can do, and the sun gear will be rotating the outer gear, which I have shown by the red color. You can see that this will be having the internal teeth. It will be having the internal teeth. But here, another one thing you have to remember: this outer gear, which will be having the internal teeth, it will be stationary. It will be stationary. And even the arm also, you can see that arm, which will be mounted on these planetary gears. And the sun gear and this will be stationary, and the planetary gears will be rotating. This may be required for some other mechanisms. Okay, one thing, please look into this. The sun gear will be stationary. The outer gear, which will be having the internal teeth, will be stationary, and only the planetary gears will be rotating, which will be fixed on the arm. Those will be fixed on the arm. This is how this particular feature gear arrangement will be called as the epicyclic gear train system. Epicyclic gear train system consisting of one arm, one sun gear, and 3 planetary gears, and another one, the last one, internal threaded one gear. Okay, this you try to remember. I do to understand. I have given this. You have to write that figure if you happen to get. Okay, this is about Now, what are the applications of the gear trains? What are the applications of gear trains? The main application of the gear trains will be to increase the speed or to decrease the speed will be using the gear trains. Okay, to increase the speed or decrease the speed will be using the gear trains. Or to have the connectivity between the two gears, those are having slightly a distance between them will be more. That time we will be using the intermediate gears, which will be helping them to transfer the power. Second, and sometimes I need to change the direction of rotation. I need to change the direction of rotation. That time I'll be using the gear trains. These are the most possible use of the gear trains. I'm not talking about the gears. I'm talking about the gear trains. Why you are using more than two gears in a system to change the direction of speed, to change the speed, maybe increase speed or decrease the speed, okay, or to fill up the gap between the two gears. And you may ask me, you can take very bigger gear. If you go for the bigger gear, one smaller gear will be costing you a lot. And if you go for the bigger gear, the cost of this gear will be maximum. The maintenance will be maximum. Right now, to avoid this, we have to go for the smaller gears in between. Now,